Hey everybody, welcome back. This is the first installment of the math portion of the ATI TEAS study group that I've put together. Today is going to be kind of tricky because what I'm going to do is to work out the math problems, I'm going to use my tablet as a whiteboard. So give me just a minute. So I'm going to use my tablet as a whiteboard. And what I'm going to do is that's how I'm going to work out my math problems with you to actually show you what's happening, because I just can't use, my other surroundings behind me, and I don't have access to a whiteboard to show you it. So this is the best option. I apologize for my terrible handwriting, and I apologize for my tablet is really old, so the screen is not the best, but she works, and so we're just going to roll with it today. Okay, so without further ado, so what I'm going to be doing is I'm going to be switching the screen share from the PowerPoint presentation to the screen share on my tablet. And so I apologize for the bouncing back and forth, but I think this is going to be a really good way to do this. Let me share my screen, share, get the PowerPoint going. Okay, yeah, so here's our practice questions. Seeing someone walk into the testing center. May the odds be ever in your favor. And again, like I said before, I'm just re-recording these. I don't want these lectures to be super lengthy, and I don't want them to be really difficult for you. I want them to kind of be short, sweet, but specifically to the point. Here's our funny meme for the segment, the content. When you solve a math problem 3 times and get a different answer each time. I think we can all relate to that sometimes. And I put the medications over here because math is a huge portion of being a nurse, specifically with medications and dosage calculations. A decimal in the wrong place could kill somebody. So it's really important that you know the medications that you're giving, but specifically the math that equates out to the proper dose. So today with this video, I'm only going to go to segment number 5. We're going to stop at 5, and then I'm going to do another video for 6 to 10, and then I'll do another video for the last portion of the math, just because making them lengthy just doesn't seem wise. So today we're going to convert among non-negative fractions, decimals, and percentages, perform arithmetic operations with rational numbers, compare and order rational numbers, solve equations in one variable, and solve real-world one or multi-step problems with rational numbers. In the next video that I record, we're going to do the remainder of these: solve real-world problems, apply estimation strategies, solve real-world problems with ratios and rates of change, translate phrases and sentences into expressions, equations, and inequalities. But today we're going to focus on 1 through 5. So let's keep going. Convert among non-negative fractions, decimals, and percentages. So a decimal is a number expressed in powers of 10. The denominator is the bottom number of a fraction. A fraction is a number expressed as a numerator and a denominator. An integer is a whole number and their negatives. Non-negatives is greater than or equal to 0. The numerator is the top number of a fraction. The percent is parts per 100. Place value is the numerical value defined by position. The whole number is numbers used in counting, and 0. So with these specific math problems on the TEAS, you need to know the relationship between the numerator and the denominator in a fraction. You need to be able to demonstrate the knowledge of place value within decimals, as well as defining percent as a number out of 100. So let's move on to our first problem. And what I really advise you to do with this is to get is to have a piece of paper handy. So what I want you to do is I want you, with this question number 1, it's not that A and B are the answers, it's just a heading and a subheading. So the heading for question number 1 is we're going to convert each decimal to a percent, and then we're going to do A and B. So again, what I want you to do is I want you to write this out so you can actually work out the problems with me. I think that might help. If it doesn't help, don't worry about getting a piece of paper and a pencil. I just advise it because I think it's a great way to kind of really upload that information into your brain. So without further ado, I am going to move on to my tablet. So forgive me while I tweak this. Share whiteboard. Okay, there we go. And I'm still recording. So we're going to convert each decimal to a percent. Let's start with the first one. We've got 1.22. And we need to convert this decimal to a percent. Now, the book tells you to multiply. Whoa, I don't know what happened there. The book tells you to multiply by 100. And with that, we get our answer of, whoops, come on. 122%. Now, that's great and wonderful. Oops, equals, not subtracted. That's great and wonderful to do the math, but for me, I like to cut math out as much as possible and rely on some things of repetition. So if you're converting a decimal to a percent, always know that you can just move the decimal point to the right twice. So here, I'll explain what I mean by that. So we have our decimal point right here, 1.22. We're just going to move it once, and then we're going to move it again. So that equals 122%. Hope that makes sense. So let's move on to 0.384. Again, we're changing the decimal to a percent. So we can multiply by 100, but again, I think it's just easier and smarter to just move the decimal twice, because then we have 38.4, whoa, don't know what happened there, 4%. So there's that answer. Now we're converting the percent to a decimal. So we have, oh gosh, that's a terrible 7. We have 3.7%. Now we're going to do the inverse of changing the decimal to a percent, because now we're going to change the percent to a decimal. And what we're going to do, we're going to move it to the left twice. So that changes our number to 0.737. So there's our answer. If we're changing 73.7% to a decimal, we have 0.737. Now we have a whole number of 138%. Now, since it's a whole number, we know that there's a decimal right here at the end. So if we're moving it twice, just go whoop, move it again. So if we're changing 138% to a decimal, we have 1.38. Okay. Now we are going to convert each decimal to a fraction. This is kind of tricky. So 0.3 516. And how we do that is we basically take the largest number and we change it to a fraction. So we have a number in the tenths, we have a number in the hundredths, and we have a number in the thousandths. So we know that this number needs to be over thousandths. So I'll show you what I mean by that. To change 0.516 to a fraction, we change it. The answer is 516 over 1,000. Because the thousandths is as large as it goes, that needs to be the denominator number. We can just remove the decimal and the 0. 516 over 1,000. Okay. So, same thing with 1.07. So we have a ones, we have a tens, we have a hundredths. We remove the decimal. Yeah, we know we have 107 over 100. Because the last decimal place is the indicator of what needs to be in the denominator. Does that make sense, how that works? Okay. All right, so moving on. Now we're going to convert each fraction as a decimal. So this one's easy because fractions are another way that we can express a division problem. So we have 19 over 10. Well, so with the ATI TEAS, you do have access to a simple calculator on your screen. So all you would do is you divide 19 divided by 10. That equals 1.9. So if we are changing our fraction to a decimal, you just divide. It's really simple. Okay, so I'll show you with the next one. 13 over 50. 13 divided by 50 equals, now on the calculator you're going to get 0.26. And I'm going to tell you right now, it's really important to get into the mindset of putting 0.26. Because with nursing questions, if you just put 0.26, you're going to get the answer wrong. Specifically, and again, I revert back to the idea that this is really important with medications and dosage calculations. And the reasoning behind that is sometimes there's typos. Sometimes there's handwritten prescriptions that you can't quite see the decimal. So if there's a medication where I have to give 0.26 milligrams, that's drastically different. So if somebody couldn't read the decimal, so if let's say the order just had 0.26 milligrams and I didn't see the decimal, and so I gave 26 milligrams instead, depending on the medication, I mean, that could kill somebody. It's definitely out of the therapeutic range. So when you're answering your nursing questions, specifically with math, you want to make sure that there's a 0 in front of it. And that's critical with understanding. So and the TEAS, if you see this kind of an answer on the TEAS, it's because they want you to start thinking like a nurse. So clear my drawing, moving on. Okay, which of the following percentages is equivalent to 8/5? Well, let's look at our answers first, and then we'll work out our problem and see. We've got 1.6, 160, 0.625, and 62.5. So percentages equivalent to 8/5. Well, we know that 8 can go into 5 more than once. So we know and understand that C is not an option. There has to be at least one whole number, okay? So that's not correct. We know C is not correct. But let's work out the problem and see what we can figure out. Okay, 8/5. So let's divide 8 by 5, and that equals 1.6. But we're not done there. We're looking for the percentage, not the decimal. So we have to change this decimal to a percentage, and we do that, again, by moving our decimal to the right. Okay, 160%, is that up there? Yeah, it is. It's option B. B is the correct answer. Okie dokie. Which of the following fractions is equivalent to 83.1%? 831 over 1,000, 831 over 10, 831, or 83.1 over 10, excuse me, 831 over 10, or 0.831. Well, we know for right off the bat, D is not correct because we're looking for a fraction. So 831 over 1,000, 831, or I'm sorry, 831 over 1,000, 83.1, or 831. Okay. So let's put 83.1. Let's change that percentage to a decimal. Well, we're going to move that decimal point over twice. So that means that it's 0.831. Well, we're changing the decimal to a fraction. So remember, we have to go to that last place. That's the thousandths. So we have 831 over 1,000. So let's look at our answers. Well, there it is. Answer A, 831 over 1,000 is the correct answer. Okay. Let me clear my screen. Let me stop my share, at least for my tablet. And then I'm going to share the screen from PowerPoint. Okay, perform arithmetic operations with rational numbers. This is our basic arithmetic. This is our addition, our subtraction, division, multiplication. A mixed number is formed by an integer and a fraction, so that's the whole number at the beginning and then a fraction. Order of operations is that PEMDAS, the parentheses, exponents, multiplication, division, addition, subtraction. So with these math questions, we need to complete computations with integers using the 4 basic operations, using complete computations with decimals using the operations, fractions and mixed numbers using the basic operations, and complete computations involving the order of operations excluding complex fractions. So let's move on and we'll look at the options. Again, I took a picture of the book because for me to try to write all these out would be really, really difficult. So if you want to pause this, write these out, we'll go through it. I'm gonna get a drink really quick. And then I'll share my screen and then we'll work it out on my whiteboard. Not more than that. Okay. So let me stop my share whiteboard. Okay. PEMDAS. Please excuse my dear Aunt Sally. This is the order of operations. Anything that's in parentheses is done first. Then we look at exponents. And then, so with multiplication and division and addition and subtraction, these are interchangeable. It just depends on which is first, looking at the equation, going from left to right. So if we have done all of our parentheses, we've done all of our exponents, and there's a division portion right here, and there's a multiplication portion right here, we're going to do the division portion first because it's at the beginning of the equation. We don't have to do the multiplication first because it's in this order of operations. What I mean by these are interchangeable is that depending on which comes first in the equation from left to right, you can do it. But if, like this over here, if there was an addition problem right here and a multiplication problem over here, we do the multiplication problem first. Oh gosh, it's a terrible one. We would do this multiplication problem first because it comes before the addition. I hope that makes sense, and it should make sense as we kind of go through these. So the first one is we have 4 plus 3 times 9 minus 6. So, well, let's look at this. What do we do first? There's parentheses, 9 minus 6, which equals 3. 4 plus 3 times 3. Well, again, like I said, if we're going from left to right, we would do the addition first. But because we're following the order of operations, we need to do this multiplication part first. So 3 times 3 is 9. 4 plus 9 equals 13. Okay. Next one. We have 2 parentheses in this one. 12 minus 2 divided by 11 minus 6. So let's do the first parentheses. 12 minus 2, that's 10. 11 minus 6, it's 5. So 10 divided by 5 equals 2. And if any of these you're struggling with or it's not making really clear sense, Khan Academy is wonderful. Khan Academy is wonderful with understanding the order of operations and complex, not necessarily complex, but these equations. So here we have 6 times 5 plus 4 divided by 2 minus 2 times 5. Now, if you have an equation like this on your exam, you can just plug it in. You can just plug it in. It's going to give you the answer you want. But we need to be able to do it by hand to understand the process of it. So there's no parentheses, there's no exponents, there's multiplication though. So let's do 6 times 5 is 30. Okay, well, there's plus. Let's keep moving down the line. 4 divided by 2 is 2. Keep moving down the line. 2 times 5 is 10. And we can just drop these operations because we've broken these down basically into their own parentheses. So 30 plus 2 minus 10. 30 plus 2 is 32 minus 10 equals 22. Okay, this one has is a fraction. This next one's a division problem. So it's written out as 30 minus 3 times 2 over 18 minus 24 divided by 2. Now, you don't have to be intimidated with the fact that there's a fraction here. How we can redo this equation is basically by turning these into a parenthesis and then this fraction symbol into a division symbol. So I'll show you what I mean by that. 30 minus 3 times 2 divided by 18 minus 24 divided by 2. Okay, so we're going to do PEMDAS within the parentheses. There's no parentheses within this. There's no exponents, but there is multiplication. So this changes to 30 minus 6 divided by, 18 minus 24 divided by 2. So we're going to do the division before the subtraction. 24 divided by 2 is 12. 18 minus 12. Now we can break this down even further, removing the parentheses completely. 30 minus 6 is 24 divided by 18 minus 12 is 6. I had to double check that on my calculator. So 24 divided by 6 equals 4. Let me double check, make sure I did that right. Where is it? Okay, yep. All right, which of the following is the correct value of 3 plus 2 times 6 minus 4? Well, let's look at our answers. We have 32, 10, 11, and 26. So we know that our answer should at least mirror one of these options. I know you can't see that because we're looking at the whiteboard, but those are our options. So 3 plus 2 times 6 minus 4. Well, there's multiplication right here. 2 times 6 is 12, and that changes it to 3 plus 12 minus 4. Well, we're going to go left to right. So what's 3 plus 12? 15 minus 4 equals 11. C is 11, so C is our answer. Excuse me. Which of the following is the correct value of the expression below? This is one of those, this is another one of those equations that has a fraction in it. So it's written out as 15 plus 2 times 5 over 11 minus 24 divided by 4. So remember what I said before, we're just going to change this into parentheses. Okay, so I'm going to clear it and rewrite it. 15 plus 2 times 5 divided by, oh, come on, 11 minus 24 divided by 4. Sorry for my terrible handwriting. It's really rough being a lefty because all of my other little operations are on the side here. Okay, so let's break it down. 2 times 5 is 10. 24 divided by 4, 6. Okay, so now we have 15 plus 10 divided by 11 minus 6. Well, 15 plus 10 is 25. 11 minus 6 equals 5. 25 divided by 5 is 5, and B is 5, so we know we have the right answer. Cool. Moving on. me stop my share here and come back to my PowerPoint. Okay. Thanks for being patient, guys. Compare and order rational numbers. So we need to know the common denominator, the decimal place value, inequality symbols, irrational numbers, multiples of a number, ordering numbers, and rational numbers. If you need a moment to pause the video to familiarize yourself with these terms, please go ahead and do so. But the whole point of this aspect of the exam is that you need to be able to demonstrate knowledge of the meaning of rational numbers, know the terms and symbol for less than, greater than, and equal to, ordering 3 or more quantities, least to greatest, greatest to least, comparing 2 quantities using symbols, know place value with decimals, rewriting numbers to have a common denominator. Hang on. Okay, we're going to write in increasing order. -5, 5 2/3, 0.523. Okay, then we need to do which of the following is an expression to compare 8.33 and 8 2/3. Which of the following lists the numbers in decreasing order? 0, 2, -2, -0.2, 2/10, and 2. So if you want to write these down on your piece of paper, I encourage that. Go ahead, pause the video again if you need to write these out, but we're going to just keep plowing through and work on my whiteboard. Okay. So write in increasing order. -5, 5 2/3, 0.523. So if we're looking at a number line, and we know that this is 0, we need to write in increasing order. So we need to start from the least to the greatest. Well, we have -5. So if we have 1, 2, 3, 4, 5, -5 is right here. And then we have 1, 2, 3, 4, 5. And 5 2/3 is going to be probably about right here. And then we have 0.523. Well, there's nothing in the ones position of 0.523. And we know 0.5 to be half. So this right here is 0.523. So if we're, again, writing our answer in increasing order, we know that it starts at 0.5, 0.523, and 5 2/3. Okay. So, whoops, my fan fell over. I don't like that. Okay. So that's our answer to write in increasing order. Now let's move to the expression to compare 8.33 to 8 2/3. So let's look at it like this: 8.33, 8. Whoops, I don't know why I did a decimal there. 2/3. Okay. Well, first things first, we have to figure out what 8 2/3 is. And again, we have to change it from a fraction to a decimal. So to change it to a decimal, we need to put it into a improper fraction first, and then do the math on it. So 8 times 3 is 24. Plus 2 is 26. Whoops. So we have 26 divided by 3. 26 divided by 3 is 8.66666666666. So if we want to round up, We can do 8.67. That's what 8 2/3 is. So which is greater? Which has the higher value? And we know and understand that there is greater, whoops, we know that there is greater than, less than, equal to choose from. Remember back in elementary school, we needed to know which the hungry alligator wanted to eat. He wanted the bigger food. Which one's he going to eat towards? So you know that 867 is greater than 8.33. Okay. Which of the following lists the numbers in decreasing order? -2, -0.2, 2 and 2/10, and 2. So again, let's draw that number line. We have 0 here, and we're doing decreasing order. So we want to know the greatest to the least. Okay, so we have -2 over here. Well, if this is -1, this is going to be -0.2 right about here. And then we have 2 right here. And then we have 2/10. So if you wanted to, you can take that 2/10 and work it into a decimal and figure that out. But we understand that there's a whole number of 2 and then additional fraction on top of it. So it's going to be right here. So to write from decreasing in decreasing order, we have 2 and 2/10, 2, -0.2, and -2. Well, that is option D. There's our answer. 2 2/10, 2, -0.2, -2. D is the correct answer. Okay, so sorry, let me stop my share again. Share my screen up here. Okay, moving on. Solve equations in one variable. Again, if you need to pause this and familiarize yourself with these terms, I'm just trying to kind of streamline this. But there's algebraic equations, combining like terms, there's a constant, inverse arithmetic operations, reciprocals, variable terms. If any of these are kind of like, whoa, I have no idea what that is, again, I encourage you to refer back to the study helps that I encouraged online. But the questions that you'll come into contact with on the TEAS, you need to be able to understand the meaning of a variable, understand the structure of an algebraic equation, demonstrate the knowledge of inverse arithmetic operations. So question number 1 is x minus 5 equals 32. Solve for x. Solve x plus 7 equals -3x. Solve 3x equals 10. Solve x over 5, or 8 over 5 times x equals 6. And then given the equation 2x minus 3 equals 5x plus 4, which of the following is an acceptable first step towards solving the equation? Subtract 3 from both sides, add 4 to both sides, subtract 2x from both sides, add 5x to both sides. So if you need to pause and write this out so we can work on this together, I highly advise that. But I'm going to get this set up to where it's sharing from my tablet. Okay. So the first question is x minus 5 equals 32, and we're going to solve for x. I don't even want to really look at the options for the answer of A, B, C, or D. I want to be able to know how to do this myself. So first things first. Whoops. X minus 5 equals 32. So in order to isolate x, we have to remove the other variable. So we just add 5 to both sides, because then that makes x equal 37. 37 minus 5 equals 32. Well, or I'm sorry, 37. 37 minus 5 equals 32. So x equals 37. B is 37. That's an option, so we know we have the right answer, B. Okay, we're going to do the same thing. X plus 7 equals negative 3x. Now, how we want to isolate this is we have to subtract x from both sides, because we want all of the variables on one side so we can figure out the equation. So we would subtract x from this side. So we have 7 equals, so we know that negative 3 plus negative 1 equals negative 4x. And so the same thing, you can do negative 3 minus 1. It's still going to give you negative 4. Sorry, let me try a different 4 with that. That's a little better. So now what we have to do is we have to divide negative 4 from both sides. So we know that negative 7 over 4 equals x. This is our answer. Okay? Sorry for the squiggles. Does that make sense? Okay. Moving on. 3x equals 10. Well, we got to isolate the variable. We have to get that all by itself. So we divide by 3. X equals 10 over 3. That one was actually really easy because there's only one step. But there is our answer. Okay, this one's going to be kind of tricky. So we have so what we have to do with this one, here, let me just clear it and then I will draw it back again. When you have a multiplying fraction, to get rid of it, what you have to do is you have to multiply it by its reciprocal to remove it. So what we have to do is we have to multiply this by 5/8, and we have to do it to both sides. Okay. So this right here eliminates this and it isolates x by itself. So then we have to multiply 6 by 5/8. Well, and what we would do with this is we have to cross multiply. So 6 times 5 is 30. 6 times 8. Well, actually, because it's 6 over 1, 1 over 8 is, or 1 times 8 is 8. So let me take this and just move it on over here. So now we have 30 over 8. Well, that's not simplified. We can go even less than that. We need to find a, we need to just kind of simplify this fraction. Well, we know that these both can be divided by 2. 30 divided by 2 equals 15. 8 divided by 2 is 4. And that is as low as it can go because these can't be divided by the same number anymore. So we know 15 over 4, whoops, equals x. that makes sense. How we got to that. Okay. Now, if we are given the equation 2x minus 3 equals 5x plus 4, what's the first step that we do to solve this equation? Well, do we subtract 3 from both sides? No. If we were going to try to do that, we would add 3 to both sides. So we know that A is incorrect. Would we add 4 to both sides? No, that's also incorrect. We would subtract 4 from both sides. Would we subtract 2x from both sides? Yes, C is our answer. We would subtract 2x from both sides because that removes the variable on this side so we can figure out the equation. And to emphasize even further, option D is add 5x to both sides. And again, that's also not correct. We would not add, if anything, we would subtract. And we're going to try to subtract the least from the greatest. So trying to subtract 5x from 2x, we can still do it and still find out the answer, but it's easier if we subtracted the 2x from the 5x because that makes this integer still positive and avoids going into the negatives. Okay, so C is the correct answer, subtract x from both sides. All right, guys, this is the last portion. This is the last portion we're going to do for this video for the day. Key terms with solving real-world one or multi-step problems with rational numbers: contextual, erroneous, extraneous, operation, repeat, solution, terminate. Familiarize yourself with these. If you need to pause and read over them, if you need to, go ahead. But the main part that we need to be able to understand with these questions is we need to differentiate among necessary, erroneous, and extraneous information in a word problem, determining necessary operations from contextual clues in a word problem, perform arithmetic operations with rational numbers in a real-world context, checking the reasonableness of the solution to the problem, solving equations in one variable in a real-world context. So, George wants to use square pavers that are 6 inches on each side to surround his flower garden. The garden is 12 feet long and 3 feet wide. How many pavers should George buy? So we'll do that one first, but I'm going to continue reading to this other one. The cat owner gets a vitamin prescription from his veterinarian that lists the dosage as 5 millimeters BID, which is twice a day. The bottle contains 30 cc's. How many days will the bottle last? Okay, so again, let me stop my share with the PowerPoint, and I'm going to share with my tablet so we can work these problems out. So George wants to use square pavers that are 6 inches on each side. So they are literally squares. 6 inches by 6 inches. And he wants to surround his garden that's 12 feet long and 3 feet wide. Okay, so if we know that there are 6 inches in a foot, to find out how many pavers we need on one side, we need to multiply this by 2, because we know that there's 12 inches in a foot. That means that we need to double this. So to find out how many feet of pavers we need to times 6 times 2 times 12. I'm going to come over to my calculator. 6 times 2 times 12. Wait, whoops. think I did that wrong. Okay, I'm sorry. I apologize. I'm doing this wrong. Okay, so we need to double this number, 12, because we need, for every foot here, we need 2 of these. So we need 12 feet times 2, because 2 of these make a foot. That means we need 24 pavers on this side. I'm not going to write out all the, but we know we need 24 pavers over here. And we also know that we need 24 pavers over here. Okay, so now let's do the 3-foot sides. Okay, and we're going to do the same thing. If we know that 2 of these pavers makes up a foot, 3 times 2, whoops, equals 6. 1, 2, 3, 4, 5, 6. 6 pavers. 1, 2, 3, 4, 5, 6. 6. Now, that doesn't completely enclose the whole garden, doesn't it? That leaves these 4 corners empty. So, how we break this down is we need to have, here, let me erase this. We need to have 24 times 2 plus, come on, 6 times 2 plus 4. So let's figure this out. 24 times 2 is 48. 6 times 2 is 12. 48 plus 12 plus 4 equals 64 pavers. Okay? That's the easiest way to figure that out. So we know that he needs 64 pavers to pave his entire garden. Now, moving on to the cat owner with his 300 milliliter, or I'm sorry, 300 cc bottle of vitamins. So the cat needs 5 mLs BID, which is twice a day, so times 2. We know that the cat needs 10 milliliters a day. Well, we need to know how many days the bottle is going to last. Well, 300 cc's is equal to, oh my gosh, 300 mLs. So, because a cc is equal to a milliliter, they're the same. So what we do is we have 300 mLs, and we know that the cat's going to use 10 milliliters a day. You divide it. 300 divided by 10 equals 30. This is a 30-day supply. Again, sorry for my terrible handwriting. Okay. All right, that's all for this. I'm going to stop with this for right now. I will continue recording in just a minute after I kind of get my brain to reboot. Yep, I'm going to see you guys later, I guess. Bye.